Hello everyone, and welcome to a new community webinar. This time we'll show you how to start an IoT project, deal with larger amounts of data, and eventually scaling up your solutions to make them production worthy. My name is Jan de Vries, and I'm Community Engagement Manager at Mendix. Next to webinars, I organize meetups, manage the MVP program, and much more. So with me today is Mendix expert, Mendix MVP, and overall cool guy, Willem van Zandvoort. He's been building IoT solutions with Mendix for over 5 years and is an all-round platform expert and is often involved in IoT projects. So welcome, Willem.
Thank you, Jan. It's very great to be here. As Jan said, I'm a senior Mendix consultant and a Mendix MVP at Time Series. And I'm excited that you're tuning in to watch this webinar because today we'll be talking about the awesome world of IoT and Mendix. So let's get started.
Cool, let's do it. During the webinar, you can ask your questions in the new Mendix community Slack. Click on the green button in the webinar window to join. You can ask your questions in the webinar channel. At the end of the presentation and the demos, we'll try to answer them as best as we can. So our goal for this webinar is to get you the knowledge and the how-to to build real working IoT solutions that add value to your customers through hands-on examples.
Yeah, we'll do this by starting simple and then accounting for increased data and eventually scaling up your solution for production. I'll also be going over a number of best practices for developing IoT solutions.
And to round up, we'll take a look at what's next in the world of IoT and share some resources to get you started today, like blogs, videos, and App Store content. So, Mendix is a great tool to create IoT-related apps. You can build a proof of concept within hours if you want to if you have the right sensor kit and an idea of what you want to build. However, when you want to scale your IoT solution, you'll quickly run into a huge amount of data. If you saw Simon Black's webinar from 2 weeks ago, you already have a good impression on what IoT is and what these setups generally look like. If you haven't seen it, it is well worth the watch. Simon talked about the Mendix platform, the IoT architecture, IoT platforms such as AWS and MindSphere, and how to integrate those platforms with Mendix. And what I will be focusing on is the Mendix side of things and how you build those integrations. So by the end of this webinar, I hope to have accomplished at least one of the following things. 1. Show you how easy it is to get started with IoT. Prepare you for dealing with increased amounts of data. Provide a comprehensive view of the technical requirements of building a production-worthy IoT solution. And eventually inspire you to start now. So let's start simple with a prototype. What I have with me today is called a Nordic Thingy. It's a Bluetooth prototyping sensor kit, which is a very accurate name. Because instead of the sensors that we will be showing you in the next examples, this thing connects directly to the Mendix client. So it is connected via Bluetooth, and we recently released a App Store module to connect to devices like this. And as you will see, it's implemented in a matter of minutes. So let's do that. Cool. Demo time.
Let's turn it on. You can see it's turned on. I'll put it down somewhere over here. And let's switch over to the Mendix project I prepared for today. So first things first, let's get the Bluetooth App Store module. It's this one.
So this is a connector built by Time Series.
Yes. Yeah, that's correct. And as you will see in a bit, it's a very straightforward App Store module.
And it's available for everyone, right?
Yeah. It holds a single entity with a value. We'll be adding one later on. But just to show you what's in here, we also have 2 JavaScript actions. One to connect to the device, and one to get notifications from the different sensors that are in the IoT kit. So, let's get started. What we will be doing in a bit is I'm going to create a page, and we're going to show the data that's coming from this sensor on the page.
Cool.
We'll be connecting to 4 different sensors on this device, and to keep them apart, I'm going to add an attribute on here that is called measurement type.
So of course, I'm really curious, what type of information is it going to measure?
Of course. Well, I can show you in a bit actually, because it's in the Nanoflow action that we'll be implementing.
Okay, perfect.
So we need to create a page. It's going to be a blank page, and we'll call this Bluetooth data. Okay. We'll add a building block, a page header that says Bluetooth data. And we'll be showing the data in a list. We won't need this one. So what we need to do next to show this on the page, we need to create a wrapper, because that's what we'll use to connect the measurement data to. So we'll call this measurement wrapper. And we'll add an association to our App Store module measurement. And it's going to be connected to multiple measurement objects. So with that in place, we can also add the data view to this page. Select the measurement wrapper. And then we will be adding the list with our measurement. Okay. And what we will be showing is not the name, but we will show the measurement type first and the value second. Okay. So this is going to be 1 and 2. And with that, we have everything in place to show the data on the page. But then the next thing is we are going to connect to the device. I have already created a Nanoflow action for this, because otherwise I would have to be copying all of these unique identifiers, and you get the gist after one, I suppose. So first...
So what are the unique identifiers in there?
Yeah, that's a good question. The unique identifiers, because this is a Bluetooth device, you speak directly to each sensor. So, for example, your question earlier where you asked, what kind of sensor data will we be reading? We'll be reading humidity, temperature, the CO2 value, and pressure. Right. And all of these sensors have a different identifier that we need to connect to get the data from it. Same thing goes to connect to the device. We're going to drag in the device connect from the App Store module, and I will need these identifiers. Copy, okay. Because this takes 2 unique identifiers. It's very easy to find these identifiers if you find the documentation of the different types of sensor kits that you want to implement. It's not like I'm plucking them out of the air. These are actually in the documentation.
So each sensor has a unique identifier that you can find in the documentation of the device itself?
Yeah. So if you go to the website from Nordic, then they have enormous documentation, and you can find all this information on there. So this is the primary ID, and then I need to add the optional one. Okay. Paste this here. Okay. I don't need return variable. So what this action does, you'll see in a bit, it will show a prompt where we can connect to the device. And because we've added these unique identifiers, it knows which device to connect to. We will be creating a pressure measurement. So create an object from the Bluetooth connector. And we will call this pressure. And we'll also set the association with the measurement wrapper. Okay. Then finally, to actually get the data into the object, we'll add this JavaScript action, copy this UUID, and paste it in here. So this is the characteristic UUID. We'll also need the optional one. And then add the measurement object and set the uint16
this describes the amount of bytes that can be inside the value. It's pretty technical, but by setting it to false, it will work properly.
Yeah, it's just a required value that you just need to set.
Yeah. All right. With that in place, I think it's ready to do a test.
Great. Let's see it.
Set here. It wasn't necessary to put add. Okay. Yep. Save and build. So the device is turned on. You can see it. Yeah.
Mm-hmm. Yeah, so it's blinking blue.
Yeah. It actually comes with a an app on your mobile where you can also connect it with, and then you can change the colors and you can have it play a sound, and it's pretty cool.
That's cool.
It's fun to play around with.
So how much would a sensor like this cost?
I think this one costs about 30 euros, 35 maybe.
30 euros, that's really cheap.
Yeah, especially if you see, if you look at how many sensors you get for a price like that.
Yeah. All right, let's take a look.
All right. Okay. The only thing we didn't do
You didn't
is
add it to the
add
home
the page. Yeah. All right. So because our Bluetooth data page expects the wrapper object, we'll create a microflow where we create the wrapper. Show Bluetooth data. We'll create the measurement wrapper, and then show the page with the measurement wrapper. And then we'll put the microflow in here. So if I click this in a bit, it will trigger the microflow, show the page.
Perfect.
And then, of course, we need to include this. We'll connect the device. Okay, so that said, we have this nifty button here, connect the device. You can see it will start scanning, and it found a thingy. So we'll hook it up to our client.
So that's what it's called by default, thingy.
It's a thingy, yeah.
It's a thingy.
It's a thingy.
Oh, it just blinked green to show that it was being connected. Yeah.
Yep. So what you see on my page here right now, you can see the pressure, you can see the temperature. It's a nice 25 degrees in here, the humidity, and the CO2 value. And, well, we can't do anything about the temperature, but if I hold it in my hands, you can probably see the humidity spiking a bit.
You have such clammy hands. Will.
Yeah, that's me. Probably not the best idea.
Oh, yeah, see, it's going up
it
60, 62, 64. Yeah.
So, and that's how easy it is to connect one of these Bluetooth sensors to your Mendix application.
Wow,
And
that's awesome.
yeah, and I would say this is basically all you need to create your first IoT application. That was our first example. It was one sensor with a tiny bit of data. And what I want to show you now, if we take that one sensor, but increase the data axis. So for that, I brought this thingy. We used it for, I would say, a prototype. It's a P1 monitor. You hook it up to your smart meter at home, and it extracts data from your smart meter and sends the data every 10 seconds to the cloud. In this case, the cloud is our time series IoT platform. And it does that by connecting this thing to your Wi-Fi at home. So it's pretty easy. And we will be using a REST integration to extract data from the IoT platform. The implementation is also fairly easy. And what I think is worth pointing out that 10-second data sent every 10 seconds is 8,640 measurements per day. And that's from one sensor, so you kind of get the gist of how much data that can become. But without further ado, let's go into the demo. Okay. So, we'll close everything here. And we will be creating a similar setup like the Bluetooth sensor, but this one is for our smart meter data. So, I will start out by creating a microflow. It says show smart meter data. we'll do the same thing as with the Bluetooth. We'll create a wrapper object, and we will be showing it on a new page. Blank. Smart meter data. Okay. So back to the microflow. Add this. Okay. On here, we'll do the same thing. We'll add a nice header so we know on which page we are. This one is called Smart Meter Data. And we will add a data grid inside a data view with the measurement. But we don't have anything to show in our data grid yet. So that's what we'll do next. So when you implement something from a IoT platform, I genuinely hope that you have some kind of documentation. So in this case, we have a Swagger documentation that's been provided to us. And I have it over here. There's a lot of different API calls that we can make to a lot of different endpoints. And today we'll be implementing the between dates. So I will be extracting the raw measurements from my actual smart meter at home from this morning up until now. And we'll do this by implementing this one. I already prepared the API call I'm going to make, but I need to edit. No, wait. We need to hook it up to something first. So we'll copy the schema and create a JSON snippet. And what this will do is it will tell Mendix, sure, what kind of data will come from calling that endpoint. So this is a decimal. And if we refresh this, this is our raw measurement. Okay, so with this JSON structure, we can add an import mapping for raw measurement. Okay, and we'll base it on our JSON structure. And what do we need? We don't want the array, we just want the objects, the date time, and the value. And we'll hook it up to our measurement wrapper. I like this option map automatically, because what this will do is it will create a non-persistent domain model for the data that will be coming from the web service. So, with that in place, we can create our page, add the raw measurement to the data grid, we'll retrieve it by association, show it like this. So the only thing that's left to do is do the actual implementation with the web service. So for that, I'll create a microflow, get data, edit the onClick, it's going to do a microflow call, get raw measurements. Okay. So if I go into this microflow, we'll have the raw measurement because it expects we've selected something which we haven't. We only need the measurement wrapper. This web service expects its date time to come in a very specific string. So what I did, I created a microflow already that creates the string for us from a date time. And we will be selecting the current date time. Oh yeah, I have to say this. It's actually a good step outside of this. As of 2 days ago, we implemented a new certificate on our time series website. And this device actually also needs the certificate to send its data privately. But the company that maintains these sensors is on holiday. So the data we have available is from 2 days ago. So to mimic this being live data, we'll add some days and subtract 2 days. I only need 1. Okay. So this will be our start date. And
not the current date time. We want the begin of current day. That's the start date. And the end date, that will be the current date time. So we'll do the same thing, add days, current date time, subtract 2 days. Okay, and this will be our end date. Next thing we'll do is call the web service. Let's see, REST, call REST service, the location. I pasted this one here because it's an enormous one. So what this does, the first one is the base URL for our endpoint, and next is all the parameters. So the asset ID, this points to the specific sensor I have at home. The channel is the live data, the type of data is the registered data, and the start date and end date. That's what we've prepared just now. So the base URL, I put this in a constant value. The start date is going to be the second one, and the end date is going to be the third one. We'll do a get operation, and of course we need to add some authentication. I know this is admin, and the password I have to get from here. Let's paste this, okay. And the request is always empty. And the response will use our import mapping so we can make sense of what's coming back. So we'll apply the import mapping. Which one? The raw measurement that we just created. We'll give it the measurement wrapper so it can connect all the measurement data that comes in to our wrapper. And we'll put the output in a raw measurement list. Okay. In case this fails, I'll set some error handling. Set this one as the error handler, and what will this do? It will show us a message that something went wrong. And it will say, whoops.
That's very descriptive.
It is, yeah, you shouldn't do this in a real implementation, but you get the gist. That's, I'm not following any conventions at all here, but yeah.
Yeah, we just want to get the data.
We just want to get the data, exactly. Yeah, so the data.
So kids, don't do this at home in your production systems?
Add some conventions. The only thing that's left to do is change the measurement wrapper so it refreshes. Okay. What I'm also going to add is some kind of logging. So we'll see how long this API call takes to complete. That will give you a sense of how long it takes to send data over the line. We'll do this by creating a variable. It's a date time because this will hold our current date time. So this is the start. So what we can then do after our call is finished, we can create login message. Info, let's call this raw measurement. Okay. And what it will say is the seconds between the start and again the current date time. And obviously this needs to be a string. So to string. Okay. Time to complete microflow is that many seconds. Okay. We have error. Oh, wait. Okay. I think it's time to do the call.
Cool.
Let's see if we did everything right. We have our home page. We don't have it connected yet. See? Show smart meter data is going to go into this button. It will create the wrapper, show the page,
And on this page, we can click a microflow that will actually do the call and get the data. Okay, let's refresh the page and open the smart meter data. So if you click the button, it's that easy.
Whoa.
And if you can, as you can see here, it's over 3,000 objects that have been created in, let's see, less than a second. So that's not bad, right? But with this doesn't say anything. So what I would like to do next is show this in a graph. So we can see the usage for today. Well, actually 2 days ago, but
yeah.
So we will add a line chart. I will add it next to this one. Give it some space. Line. Okay. So wait, let's add this. The x-axis is the date time, and this is the usage. Show legend, yes. This is all okay. Let's add a series, and the series will be raw measurement. And here we run into the first thing that you have to take into account when working with such a large amount of data. What is going to be the data source of this chart? For now, I'll set database. I'll show you in a bit why. So the data points on the x-axis will show the date time, and on the y-axis will show the value. This is all okay. The appearance, I don't need the markers. It is static, dynamic events, everything is okay. Appearance is good. We don't use any rest, and I'll set the mode to developer. Okay. And it needs to be inside a data container. So we'll need to edit our page just a tiny bit. Place this in here, and then the whole thing goes inside the data view because it needs to be fed by a data view. So what happens if I do this? We get an error because our raw measurement is non-persistent. And if we want to have the data source set to database, obviously it means we have to save our data somehow. So for example reasons, we'll make it persistable. This is something that you make a conscious decision about this. I'm not telling you to make data persistent like this. If you want to add a line chart, and I'll show you in a bit why. So yeah, this should do it. We made changes to the data model, so we need to update our database. I will go back to the page, and we'll do this again. Get data. See? This is my data usage from a few days ago, where you can see, this is why I enabled the developer mode, because I'll show the bottom a bit more, then we can actually see the times. So down here it says 4:43, but it's UTC time, so that's 6:43. That's when I woke up, and I put my coffee maker on. And here someone's at home, so electrical appliances are being used. So this gives a bit of a better overview of my raw data, so to say. But what if I want to do something with this data? Because showing a chart is not always the best way to handle your data. Let's say I want to have the total amount of usage for today. So that means I will have to do some calculations with the data that are retrieved from the web service, which we'll do in the microflow. So when we get the data, we will take a sum of the raw measurement list, use the aggregate function, over the raw measurement list. We'll take the sum, we'll call it sum, and we need somewhere to store it in. Oh, sum of the value, of course. And we need to store it somewhere. So let's do that in a measurement wrapper. Add attribute, say total usage, and it's a decimal. So going back to get raw measurements, let's change the measurement wrapper and set the total usage with the sum. And on the page, we obviously want to show it somewhere. So let's say in here, total usage. Oh, wait. I need to place this inside the data view as well. Otherwise, I can't access the data. Select total usage. Okay. Let's see what happens. Obviously, yep. Let's go back. Let's do this again. Get the data, and we see a total usage being updated. And what I'm quite curious about is the time to complete the microflow. It hardly takes any time. But this is just one total usage for my usage today. If you work with IoT, you probably want to use the data for something much bigger. You want to do comparisons to other days. You want to show it the total usage from yesterday, the day before, or even over a week or over a year. And that's where things get really complicated. You need to find out a way to process all that data in a smart way, and it's probably not in Mendix. Because, well, let me elaborate on that a bit. By doing that, what will happen, I added it now to the microflow that actually retrieves the data, but that would also mean if the data sets get larger and larger, the end user would also be waiting for that logic to finish. And we all expect our pages to be quick, we want to have it responsive, so it's probably best to do those kind of calculations somewhere else. I'll show you that in a bit when we go to the next demo on how we solve this issue. But for now, there's one final thing that I would like to do, just to add some more flair to this, is I want to make the graph live. So show the actual movement of my electricity usage. So one of the ways I know how to do this, but probably not the best, is by adding a microflow timer. So we'll go to the App Store, add the microflow timer, and we'll get this version. Okay. And we will add it to our page. Microflow timer. Okay. So what do we want to have this thing do? Let's say I want to update it every 20 seconds, then we're definitely sure the 10-second mark has been hit. Execute it once, no. Once, no. Start it once, no, because I want to wait 20 seconds. And what do we want to have it do? We want to have it call a microflow. It's actually the same one that we just created. Okay. But that wouldn't work completely, because it would just keep retrieving the same kinds of data. What we want to do is we want to somehow store the when we finished retrieving data, so we can take the end date as the new start date. So it keeps adding data. We'll need somewhere to store that date time in. So I'll add the attribute, and we'll call this latest retrieve. It's a string value in this case. In here and set it on the wrapper. Latest retrieve is the end date. Okay. And what do we then want to do is change the call. Say if our measurement wrapper has a latest retrieve value, So it isn't empty. Well, let's do it correctly. Trim. Then I want to use that one. Measurement wrapper. And otherwise, I want to use the start date that was created in the submicroflow. Okay. And because I use this microflow as a in the microflow timer now, it expects to return a Boolean. So this will be true, and this will be false, so it can stop the timer. Okay. See what happens. Database update. Yep. Okay, let's go back in here. Let's get some data. See what happens. And this is exactly what I thought would happen, because we see the graph retrieving the data from the database, which actually takes a very long time in this case. And it will keep on doing this every 20 seconds when the microflow timer hits. So let's have a look at what kind of data is being sent to the console. We'll do this by opening up the inspector and go to the network tab. And we'll have to wait for one iteration of the graph to finish. Then we can see what kind of requests it sends to the server. But once it does, we can see how long it takes for that call to finish. All right, so it finished the calls that it did, and as we can see here in the waterfall, well, it took 45 seconds to 50 seconds for the graph to be refreshed, to retrieve its data, and then it's gone again because it's doing the next cycle. So what we want to do here is we want to change it back to non-persistent. We'll stop this first. And we'll get the data from microflow. So instead of setting the data source to a database, we'll set microflow. I will create a new one. Return data. Show this microflow. It has the measurement wrapper, so the only thing we need to do here is retrieve that data and return it. Okay, let's see what happens now. Yep, it's non-persistent now. So let's go back in here, refresh the page, show the data, get it. Boom. See how much quicker this is? Oh, I forgot to add the sorting because now it's doing it backwards, but it still gives the same idea, I suppose. So every 20 seconds, the microflow timer will now trigger. It will see if there's new data available and update the page and graph accordingly. And this is quick instead of the database retrieve. So what I want to point out with this is play around with this. Find out how data works best for your page, and think about what the end user probably wants to see, because it might not be this. It might be something else. It might be, like I said, a comparison of the total usage every day. And that is what I want to show you in the next demo.
All right, so we've had 2 demos.
Yeah.
And you've shown us some introduction about the sensors, how to connect them, how to display the data, and potentially how to deal with large amounts of data and calculating that. But let's be honest, we're only talking about 1 or 2 sensors here,
yeah,
right?
Exactly.
The question is, how do you scale this up to production for a large company, right? Because companies who might be, processing data for hundreds or thousands of users and maybe even more sensors, how are they going to deal with all of these calculations?
Exactly. That's why I also brought the next example. It is a lift box sensor. One of our clients actually uses this. It's called Lift Insight. And what they do with this, they stick it onto a elevator with magnets, and via cellular connection, it sends its data to the IoT platform. And that is where actually all the heavy lifting is done. That's what I've been building up towards. It also sends a lot of data, but what we do on the IoT platform is we divide up that data into so-called buckets that we want to use whenever that data is necessary. So I'll show you a demo application in a bit. It also uses the same kinds of integration that we just implemented. But like I said, instead of sending these enormous amounts of data to the client, it only sends the data that it needs. And I hope that will show. So, demo time again. So, let's head over to predictive maintenance, which is actually a very good example of a IoT application. So what we see here is an overview of anonymized data from real elevators. And, well, this is what we do with it. We try to predict when an elevator needs maintenance. In a normal case, an elevator company schedules, let's say, 4 maintenances a year. By adding a simple sensor like this, which only costs, I think, a few euros, we can measure how often an elevator goes up, how often it goes down, and based on the amount of rides, we know how much rides an elevator can take before it needs maintenance in general. We can predict when it needs maintenance again. So this one, for example, it is way overdue, so to see.
Is this real data, or
this is real data. Yeah.
Sample data?
No, it is real. Like I said, it's anonymized, so this one is not actually in Utrecht, but the amounts of rides it took is real. Yeah.
21,886.
Yeah. Since its last maintenance date.
So that's since last year.
Yes.
That's a huge number.
Yeah, exactly. And, well, what you can see here, it went down at 6, somewhere between 6 and 7. It went down once more, twice up. And this is all real time. As you can see, it's 12:28 now. So, yeah. And what I would like to point out is, with these amounts of data, is, well, the data points in here are not that many. We can easily retrieve all these data points because it only adds up to like 8. But what happens when I go to year? If you can imagine with the previous sensor, if I wanted to get my year data and I would retrieve all those 8,640 data points for an entire year, well, I can't even do the calculation, but it's a lot. And instead of doing that, what the IoT platform does, like I said, it divides up the data into buckets that we can easily retrieve data from. So, as you can see, it moved 15,873 times this year, and it only sends 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 data points, which is so much faster than all the data points it actually has. And the fun thing that you can do with data like this is you can display it in a really flashy manner, but you can also do something else with that data, and that is where IoT really becomes interesting by doing some calculation. For example, what I want to point out is here, the best moment to maintain this elevator is probably at 8:27, because we have all these rides. We can extract the data from, well, when's probably the best time for a maintenance, what's it called? Someone who does maintenance, to go
mechanic.
A mechanic, thank you. Yeah, to go do maintenance on this elevator.
And so, just to be clear, all of these data points are they live? Are you how are you retrieving that data? Is it in a Mendix database, or is it somewhere else?
Yeah. So what I think Mendix really excels at is saving the context data and building applications fast. So for example, the previous maintenance date, that's something that's static. That's something that we save within Mendix. Who was it done by, the type of repair, the phone number, stuff like that, save it in Mendix. Graphs like this, that's data that's being retrieved from the platform. And also the minimal traffic best moment is something you don't have to update every time, because it's probably it's calculated over such a huge amount of time that it's probably not going to change very often.
And when you say it's retrieved from the platform, you mean
the IoT platform at
the
time
IoT
series.
platform,
Yeah,
right?
So
You're using a front end, which is Mendix,
yeah,
to get insight into the data.
Exactly.
And make assumptions and view the metadata basically.
Mm-hmm.
But the actual heavy calculations are done by a separate IoT platform.
Yeah, exactly.
Right?
And in our case, we've built our own. But for the viewers at home, you can use, like Simon said, AWS, MindSphere. There are so many platforms out there that you can use to do this kind of thing.
Exactly. So use Mendix for what it's for its intended purpose, and for heavy calculations, use a platform that's built specifically for that. Right?
Yeah, to handle time series. That's where our name comes from.
Right.
Yeah. Let's do a recap. So what I hope that you took away from this is that starting with IoT can be extremely easy. Just get a sensor like this, get the App Store module and start building applications in minutes. And also that if you decide to build an IoT app, build it based on the information that you want to show or that your clients want to see. So that's a heavy role for the consultant, I would say, because you need to think about the end product that you want to show.
I think something that you also need to keep in mind is what is it exactly that the customer needs? Mm-hmm. Because these sensors keep track of and generate such a huge amount of data that the customers are not always interested in every single point of data. So I guess the trick here is figuring out what's important, and does it need to be real time?
Yep.
Or is it data that you can actually store? So maybe, if they want to look at and compare data between months or weeks or years, that's not real-time data.
Mm-hmm.
So can you give an example of when you would need real-time data?
When we would need real-time data? Well, alerting, for example. Alerting can be something that you do in Mendix. You want to show an alert when a value hits a certain threshold, for example. So let's say, I think Simon actually showed a good example in the webinar a few weeks ago. If a value gets above a certain threshold, it will start showing alerts to the end user saying, hey, something is wrong, you should probably go check it out.
Right.
That's when you need the real-time data. Yeah.
Cool.
So, another thing is try to keep the heavy lifting outside of Mendix. Of course, I'm not saying you can't connect one of these things to a Mendix application, because you can, but you have to make some really good conscious decisions about it, how you handle your data, when you handle the data. Do you do it when the client asks for it, or do you do it beforehand? And I think what you'll eventually end up with is that Mendix will hit its max, and you need to look for solutions like an IoT platform. So that brings us to the next conclusion, that use Mendix for things that it's good at, because IoT and Mendix is the perfect combination. And you can sit down with your client, you can show them the flashy front end that you built for them, and they'll probably be very happy within a few weeks.
Yeah, exactly. So it's quick to get started with IoT and doing everything in Mendix.
Yeah.
But as we talked about before, as soon as you want to scale up, you probably have to start looking at specialized IoT platforms, like the time series or MindSphere,
AWS, IBM.
Yeah, exactly. Yeah, the Things Network is one of them as well.
Yeah, also, yeah.
But I think a conclusion to this is IoT is awesome.
IoT is awesome. Yeah, definitely. Yeah.
Yeah, and so to help you on your way and get you started on IoT, the question is, how can you start and what's next? So there's a couple things that you can do. You can read some of the blogs. For example, from Time Series, we have 2 blogs about IoT, getting started, how to build your own OK Google and Google services integration, setting up the voice commands, letting it connect to all your data and all your sensors. But we also have videos, so we have a couple of other webinars that go in depth about how to build this, just like we did today, just different cases.
Yep.
And if you want to get started with building an app, have a look in the App Store So we've got the Siemens and MindSphere starter application. This is a really good application to get a sense of what an IoT application looks like, all the components that are part of that, how the integration works, and how to display that data to your end users. Yeah, there's various other content that's really going to help you get started with IoT. So my message would be, get started today, even if it's just a simple thing, a cheap sensor, just some data. Try to figure out how it works, and you'll quickly discover that it's easy. It's easy to get started once you get the hang of it, and you're going to want to scale up pretty quickly.
Yeah.
And you're going to get ideas that are really going to help you build really cool production value apps. So yeah, I hope we've inspired you today to come up with ideas of how you can help your customers build better apps using IoT.
Yep. Like, there's one thing I would like to add is that if you start simple. Start with a sensor like this, because the idea is so easy. Just measure when an elevator goes up and down, and from this you start to create value. And you'll probably run into some other things that you also want to monitor that will expand the value that you can add to your client.
Yeah, and it's trial and error. Get started, and you'll figure it out along the way, and start building really cool applications.
True.
All right, so that was the webinar for today, and now it's time for the Q&A. Let's get started. So we already have a couple of questions in the Slack channel, in the webinars channel, and with me here is obviously Willem van Zandvoort, MVP, and also from time series Eva Boeyen. Welcome, guys.
Thanks.
Thank you.
And let's see what kind of questions we have. So we first have a question from Bart, and he asks, if you would use a microflow as a data source for the graph and set refresh on the graph, would that work, or how would that work?
Yeah, I think it would work. I didn't try it. After having recorded the webinar, I thought exactly the same thing. I thought, maybe I should have done that. I didn't. One of the downsides would have been that the calculation of the total sum wouldn't have worked. It didn't work anyhow because the update was built wrongly. But yeah, to sum up, I think it would have worked for the refresh part of it. Yeah.
All right. So we have another question from Willem-Jan Kortleven. Does the Bluetooth thingy also work the same way when creating a mobile app? Most devices will have a Bluetooth connection.
Yeah, also a very good question. We also have a different App Store module available that is specifically for PhoneGap. That one should work with mobile. We haven't tried this one actually, but I suppose it should work because it's all just JavaScript. Yeah.
If you want to buy some stuff, Rob Price actually put a link in the Slack channel if you want to buy some IoT sensors, so IoT sensor kit. He says there are 2 left, so get yours now. I'm not selling them, but
We get commission.
Yeah, another question here is, any ideas on how to handle large amount of data when you're using MQTT data? That's incoming.
Yeah, might be a good one for me to answer. Yeah. Well, from a year ago, we started using actually Kafka in production for these kinds of things. And well, that's actually for us now the best solution to do this. Yeah.
Okay.
Kafka, all right.
Kafka, yeah.
All right. So Abdullah's asking, would you drop some of the data intentionally because the sampling frequency is too fast? Is that a good idea if the sensor is too fast for the requirement?
I think so.
Yeah, I guess this is where our differentiation within time series comes. When do we do it in Mendix, the sensor data, or do we do it in our IoT platform? For the big amount of data or the quick data, we usually use our own platform. And then this high frequency isn't an issue. So this is really an important part when you get the requirements from a customer. What do you want? What do you need from your data? Because retrieving data is usually not the issue. How do you utilize it, portray it, make it visible, and actually add value? And then the choice between Mendix or our IT platform is usually made.
Yeah. When we were talking about this earlier today, we also had a discussion if you want to apply things like machine learning.
Yeah, you need all the data you can get.
Yeah.
You don't want to throw away data, because that's actually the most valuable thing you have in machine learning. So throwing it away would be the stupidest thing you could do if you want to do a machine learning application. But that's, again, really much depends on what the requirements are your customer have.
Yeah, I think in most cases, like having the data is not the issue, but the question is, how do you get the answers that you need from that data?
Yeah. So if the thing would be just to make the graph work correctly, then take out some data points, because I think the idea would be clear with
why build a very expensive solution if you just want to have a pretty graph?
Exactly.
No
would you lose insight if you removed it? No, then.
Yeah.
So next question from Samuel is, can we create a similar application using an Arduino module?
Yeah, why not? Go nuts. I mean, that's I think if you buy like actual sensors, they are built on Arduinos anyhow.
Yeah.
So
Can you think of limitations of implementing IoT or devices, or are there things that you cannot do yet in terms of measuring, data processing, maybe things that you've run into or that you're working on trying to solve? Because right now it looks like as long as you have the data, you can connect any sensor, you can do anything you want. Is that true, or is it more nuanced?
Of course, there's always more nuance, but the real trick is the difference between sensors and how you get the data out of them and actually combine it into a valuable insight. And the thing is, I have this data and I want it in a platform, and then the vision is everything is solved. But you need to have actually the insight and the analytics, and there is a big step after that. Just storing it is only the start.
Right.
So there lies the real challenge.
Yeah.
Okay. So the next question from Thijs is, the thing you use in the video the kind of product you would recommend to get started if you're just starting with IoT, or are there some other packages or sensors that you would recommend trying out as a first project?
As a developer to another developer, I would say that the thingy is a perfect way to start. There are other sensors. A few years ago, I bought a what was it called again? A
Texas Instruments.
Right? A sensor tag. Yeah. It used to work perfectly, but now the IBM side of that thing seems to be down. Of course, you can build your own thing around it, but haven't had the time to do so. Tomorrow it is actually a pretty good moment to let you guys know. I will be releasing a blog. I did a quick Google search on IoT starter kits, prototyping kits. So I made a small list of things that look, good in my view. So be sure to be on the lookout for that.
Oh, that's cool. Yeah, some actual things and thingies to get started with your own sensors.
Yeah,
that's awesome. All right. Do we have any more other questions on the phone from the audience? I'm really curious to find out what everyone is currently doing in terms of IoT. Like, are people already doing projects in IoT at customers, or I'd love to know from people. Are you just interested? Do you just want to know, like, I've heard this IoT for a long time, but I've never done anything with it? Or do we actually have people in the audience who work on production apps that involve IoT? I'm really interested to find out. Like, when does, where in the hype cycle are we in terms of IoT, and when does it become a practical delivery instead of just a mountain of promises, basically. And so, in your experience, where do you think we are at the moment?
Good question.
I think for some of our customers, we are really well underway in having valuable solutions. Of course, there is still a mountain of promises that we want to tackle, and we will. But I think there is actually a big business value already in the IoT solutions that we have at our customers. So
Right.
I don't think it's just promises at this point. We actually do have.
Yeah, so it's already, you already implemented IoT at a range of customers, and I mean, I can imagine that these are very, very different cases depending on the customer.
The elevator case you mentioned in the webinar, to the smart meters at energy companies. So this is very diverse.
Yeah.
But it is really easy actually to integrate these things with REST APIs and get them into the platform and show insight or analyze your productivity.
Right.
I think that's
and if you're thinking about we know we can build this with Mendix and using various different IoT platforms to do calculations, large data amounts. What is for you? What's the biggest thing that's holding you back from implementing this at customers? Do customers come to you with certain questions, or do you go to customers saying, "Hey, we have a potential IoT solution"? Do you pitch it as an IoT solution, or do you say, "We can solve your business problems," and then you just so happen to use IoT?
Well, we do actually pitch it as an IoT solution. We pitch it as either the intelligent insight solution we have as one of our templates or solutions, we call them at time series. But we also pitch it as predictive maintenance because, well, you can't predict maintenance if you don't have the sensor integration, of course.
Right.
So we do actually have some tangible solutions that we pitch at customers as IoT solutions. So.
Right.
Yeah.
That's incredible. All right, let's see. Abdullah asks, can you share the links? Yes, of course. So Willem will share the links in his blog, and we'll send out an email tomorrow with the recording of the webinar as well. So you get the link to the blog and to the resources as well. So I see some people already talked about how they experimented.
Yeah, home automation. That's as a developer, I think one of the first go-tos that you do. Yeah.
Yeah, absolutely. Yeah. Temperature and power usage. And,
doors opening and closing. You see everything.
Yeah. All right. Do you recommend to dig into IoT using Mendix Studio 8 Beta? Well, I have some news for you actually, because Mendix 8 has been released today. So starting today, you can actually build production apps on Mendix 8 using whatever you like. IoT, native mobile, pluggable widgets, all the things. So everything's being released right now. But maybe a good question for you is, when do you decide to, for example, upgrade to a specific version of Mendix? Is it are you always on the latest version, or do you wait it out a month or two, or maybe longer, or does it depend on the customer?
Well, it heavily depends on the customer, I would say. Well, there's one base rule, and that is you never upgrade directly to the latest version, because first you want to see if something breaks, and if it is something that breaks, is it something that you want to use? Because half of the time it isn't. You don't use that specific part of the Studio Pro. At Enexis, for example, we have near 100 apps, and I can tell you they're not all at one of the latest versions of Mendix. It depends on the client, it depends on the application. But usually when we start new apps, we take, we call it N-1, so the latest release -1.
Right. Yeah, that makes sense.
Yeah.
All right. So I think that's it, unless we have any more pressing questions. What I like to give everyone in the audience is start. If you haven't started yet, start using IoT. Get a cheap sensor. Start experimenting, maybe with home automation or something like that. And especially think about customers that you already have. Are there things that you can improve at those customers, perhaps using IoT? Or maybe all of a sudden you're thinking of whole new solutions and new possibilities, doors opening because you now know what you need for building IoT solutions. So, my message is, go make it.
Nice one. Yeah, this is I guess I can say that for the both of us, or for the three of us, I suppose. That we hope this was a very inspirational webinar. Like Jan said, I hope you get started right now, today. And we want to close things off with a small invitation. So if there's anybody out there that is planning on doing something with IoT, but you don't know how to do it just yet, pitch us your best IoT case, and we'll gladly come and help you out. So.
Awesome. I think that's an incredible offer. So take this opportunity to contact Willem, contact Eva, and get started. I mean, these guys can boost you all the way up to, well, we'll see where.
Yeah. Sky's the limit, right?
Yeah. Perfect. Thank you so much. Thanks, everyone, for joining us today. Please take a couple of minutes to fill out the webinar survey so that we can improve the webinars going forward. And to prevent blurry picture in the future. And hopefully see you next time.
All right.
Bye.
Bye.
Bye.